Can you hear me? Yeah? Okay. Hello, my name is Alvar Torres. I'm a senior solution architect with security with AWS based out of Ottawa, Canada. And with me is Joe, which is sitting over there. He's going to join me later. He's the staff security engineer for Airbnb. So this talk was created like everything on AWS based out of feedback from customers and other coworkers. And for me, it was kind of strange because it was like, do I really need a talk where we list every firewall service and where to use them? Then I realized security is such a broad subject that somebody working on, I don't know, let's say identity, might get lost when it comes to network security. So I was like, okay, we can start from there. So I put together a talk, and that talk was going from the instance to the edge. So from security groups to WAF. Then I got feedback again and say, well, listen, you're overlooking something that is hugely important, which is firewall manager. That will be your X factor. So it's like, okay, let's go back to the drawing board and we start with that. We'll start with firewall manager, then firewall offerings from AWS. Then Joe will join us, and I'm very excited to hear what he has to say. And then we're going to end up with some recommendations. So firewall manager, I see it like your X factor, right? This is something that is going to help you scale your team. It doesn't matter if you are a one-person security team for a startup or a very well-founded Fortune 500, because even the best teams, the best founded teams, are going to have issues finding the right people. And even finding the right people is going to take some time to, onboard them. And that's where firewall manager can keep an eye for your team and scale those policies through your whole AWS organization. So some of the services that we're going to see today are WAF, VPC Security Group, Network Firewall, Route 53, Resolver DNS that Joe is going to cover, and the Palo Alto Next Generation Firewall. We are not going to see Shield because it's not a firewall and we don't have enough time anyway. Firewall Manager sends notifications to Security Hub. And when we start covering each one of these services, there will be one slide covering Firewall Manager to let us know what can that do for our services. So Firewall Manager starts with a rule. And the rule can be as simple as when there's a new application load balancer launch, then we're going to have our scope, which is if it is in the production account or in the production OU, or it has a tag production, or I don't know, cost center X or PCI, whatever you want, then we will have our action. And our action can be as simple as create a ticket. So somebody from security goes and talks to the product team and figure out what rules are needed. Or maybe you just want to auto-remediate and have a catch-all network ACL for web ACL for WAF that's going to give you baseline protection. How do we get started with it? It's super simple. So we onboard with AWS organizations. For that, we need to use our management account. However, we don't need to use our root account. We can use an IAM user with enough privileges. That will be more than enough. And then you need to enable AWS config. In the background, config does all the heavy lifting here. It checks. It knows when something new is launched, so it pays attention and it checks your rules, your scope, and your actions in the background. For network firewall and the DNS firewall, you need AWS RAM, which is Resource Access Manager, to be able to share with your organization. So you can still write your policies and share it through RAM to the other accounts. And finally, there's a designated firewall administrator. Most of the time, it's going to be your security account, but it will depend on how your organization is created. There's nothing you need to do really to get notifications from Firewall Manager to Security Hub. If you are using Firewall Manager, you enable Security Hub, you start getting some notifications. And the notifications can be related to, AWS, Amazon Shield, that is under attack, for example. Or it could be that a security group is not well configured or is over-permissive. All those notifications are going to come your way. After we cover each service, we're going to have a too long didn't read section. This is like your elevator pitch. And the idea is that if you have to remember something from this talk, remember this, because these are the key points, right? So it's not a firewall, we know that, but it helps you scale your security posture by managing other firewalls. So it's very interesting. Then we have our security groups, and we all launch an EC2 the first time that we have access to an AWS account, and we're like, yeah, default security groups, that's awesome. I know cloud now. No, you don't yet, but at least it works, right? So we know what security groups are a firewall, they are stateful. So that means if you open, something coming out is open when you come back. Also, we usually say that it's attached to the instance, but really it is attached to an ENI, Elastic Network Interface, but that one is attached to the instance. It is used to open protocols and ports to IP ranges, or another security groups, right? So you can do that security group chaining that we use so much in the three-tier architecture. For example, you have a security group that is open to the internet, then you have a security group for the load balancer. Then you have an application security group that trusts the load balancer security group, and then you have a database security group that trusts the application security group. So what can Firewall Manager do for our VPC security groups? Well, it allows us to have control. So basically, you can create your own security group and share it with your team and your accounts, and you keep control of the security group. Everything that is inside that security group belongs to you. That's a great idea for control, not such a great idea for bottleneck, right? Because now your team becomes the ones writing those policies, and you might not want to do that. So the second option, which is, well, I'm not going to allow something super overly permissive. For example, I'm not going to allow 0.0.0/0 to be open to the world. Okay, you can do that with the audit security group rules. And then sometimes you start having something that we call security group crawl. You have hundreds, thousands of security groups that do the same. So that creates a little bit of confusion. So why not concatenate everything and start using one security group that does the same instead of 1,000. So too long didn't read, stateful, attached to the EC2 through the Elastic Network Interface. And if multiple security groups are attached, then we concatenate everything and we read it the way it goes, and we make a decision based on that. It is used to open ports and protocols to IP addresses or ranges and other security groups. Network ACL, I kind of want to be that person that brings back Network ACL. I'm kind of like, Stranger Things bringing back 80s and 90s music. It's so powerful. And because they are so different from security group, Network ACLs allows you to lock down what you are opening with security group. They're stateless, so it's the opposite from a security group. They're attached to a subnet, not to an ENI. So if you need to isolate a subnet, that's a great idea to use those. And it doesn't even reach your security group if you block it at the subnet, so why not? We say they are optional because the default one comes open by default, but you should lock it down. And as you see, there's no Firewall Manager because Firewall Manager doesn't manage Network ACL, unfortunately. So we have too long didn't read. So stateless, attached to the subnet. And here's the cool thing. Let's say you want to open your web server to the internet. So you come up and create a security group, port 443, 0.0.0, everything is allowed. That's great. A lot of customers come and say, hey, I want to block certain IPs. Should I use a WAF? Yeah, you're cool. If the application is a layer 7, but you're cool. But what about network ACLs? Let's say network ACLs, first, you need to read the weight, and the lowest number rule is the one that applies first. And it will act on the first match, like a traditional firewall, basically. So let's say I want to block a certain country or a certain set of IPs. Well, I create a rule with 50, and then I say, I'm going to block you. I'm going to block every protocol. Then I have a rule of 100 that allows all. So if I'm coming from that set of IPs, I'm going to get blocked. And if I'm not, I can go forward. So I am open to the internet. I'm just not open to the whole internet. Then we have network firewall. And as network firewall, as network ACLs and security group do for ENIs and subnets, network firewall will do it for your VPC. So it allows stateful and stateless rules. It also allows IPS and IDS rules that are compatible with Suricata. And it will automatically scale for you. No need to patch, no need to manage underlying infrastructure. And you can enforce this in every VPC and every account with Firewall Manager. So there are a few changes that you need to do to the routing table, or you can ask Joe, by the way. We've been talking about that today. So once you do all the routing, you can filter every traffic coming in and out of your VPC, right? It's super powerful. It will scale with the traffic. It will shrink when it's not needed anymore. And you have a total control. So a few things you can do. You can do stateless rules. You can do stateful rule. One thing that network firewall doesn't do is deep packet inspection on encrypted traffic. So you can still block domains by a fully qualified domain name or using SNI, which is a server name indicator, which is a part of TLS that is not encrypted that you can act on. You can centrally manage with Firewall Manager. We're going to see that in a second. And you have all the visibility and reporting with network flow logs and stuff like that. So there are a few deployment patterns that you need to keep in mind. First is the distributed deployment model. And that means there's a firewall endpoint in each VPC. So it's kind of, you live in that VPC, you protect that VPC. There's a little bit of routing that you need to do for the next hop, but basically it just works, right? And this has the advantage of, you have different business, different applications with different needs. One might be a PCI compliant, one might not be. So you have different policies for each one of those. Then you can attach it to a transit gateway. And that's the centralized way. With that, you get a lot of, you get synchrony or symmetry, really, for the traffic. And you keep the zonal belonging of the firewall. And here it's like this. Like if VPC1 needs to talk to VPC2, it will go through the transit gateway. Eventually, it's going to hit that firewall endpoint. And then it's going to go back to VPC2. And you can have the best of both worlds, right? And that will be in a case that you have a lot of traffic in one VPC, or it doesn't belong to the same business center, or whatever is the case, but you want to have an endpoint there. The rest can go through the transit gateway and through the firewall endpoint. Also, you can do the same inside that VPC with the subnets. With the VPC routing enhancement, now you can put inline a middle box, like a firewall, and make it appear in the traffic between subnets. So subnet, web subnet to talk to the app subnet has to go through the firewall endpoint. So what can be done with network firewall for firewall manager for network firewall? You can centralize the deployment. You can discover new VPCs that are launched. There is a little bit of routing that you need to take care, but it will be cached by firewall manager. So stateful and stateless rule, you choose which one you want to do. Layer 3 to 7 lives in a VPC. AWS take care of the scaling, availability, and resiliency, and software updates. You can do IPS, IDS rules with Suricata, and you can put everything into S3 for the logs, or you can stream it through Kinesis Data Firehose. Then you have Gateway Load Balancer. So network firewall is great, and a lot of customers want to use it, but they say, I already invested a lot of money in network appliances, meaning I have some kind of network firewall in my on-prem, and my people are prepared, and they know how to visualize and how to catch the bad guys. I want to use the same. And that's fair enough. So how can we help here? Some of the problems that they used to face before was you could put a next hop inside a VPC for inline traffic inspection, but it can only be one. There's no balancing between those. And you can have a passive and an active and a passive, and that's great. But you have some bottlenecks. The most you're gonna reach there is 2.5 gigs. Then the flows that they can go through that are minimized. So with Gateway Load Balancer, you get basically a layer 3 device that is an X-Hope, and it acts like a router, but in a layer 4 device that balances the traffic to allow you to scale with the traffic, right? And the only thing we need for this to work is that your appliances are compatible with the Geneva protocol. And what we do there is that allows to communicate with it, and we can know when there's a new appliance, or we can tell that appliance that is about to be shut down. So the difference is you have a network load balancer, you will have a proxy where you will connect to the proxy, and eventually that proxy will connect to the firewall, and eventually that firewall will talk to the internet. What we do is a bump in the wire. So we take that traffic, we send it to the firewall for inspection. We get the response without changing the headers, without changing anything, and we send it to the internet. If it fails, we know it failed. We can retry with a different appliance. The deployment patterns look exactly the same than network firewall, because basically it's the same technology, right? So you have a Gateway Load Balancer endpoint, and you have a fleet of appliances that are growing up and down. You can do the distributed. You can do the centralized with Transit Gateway. And a couple of weeks ago was announced that Firewall Manager can deploy next generation firewall from Palo Alto, right? So you get the same experience that you expect from a cloud native solution without having to patch, without having to scale, pay as you go, all the advantages that you came to expect, but from a third party. So you get to use your existing third party skills, leverage existing tool and practices, and you get deep packet inspection on those appliances because that's the way they work. So then we have AWS WAF, and we are moving to the edge, right? What is WAF? Well, WAF is a web application firewall. The way I see it is like a blanket that you can put in front of your application. You can put in front of CloudFront, Application Load Balancer, API Gateway, or AppSync. And the idea with this is you might have a library that is that is vulnerable to some kind of cross-site scripting, or you might have a database that is prone to SQL injection. So you put this in front. And this will remove all that low-hanging fruit, right? That's the protection that you need to give your team a little bit of time. Then you still need to patch your vulnerabilities, of course, but you gain some time here, right? And with that, you can get pre-configured rules from the AWS. So basically, it covers the common attack vectors. It's influenced by the OWASP top 10. And here's the idea. You start adding these rules. You can set them to block or count. The rules itself, the creation of those rules are free. You pay per WebACL and per rules that you add, but it doesn't matter if it's one created by you or managed by AWS. We got a lot of insight into this. We have the same team that works with the Shield team to respond to the DOS attack, and it protects Amazon.com to write this rule for us. So you have a baseline rule that is influenced by the OWASP top 10. Then you have user-specific rules, like, for example, if you're running Windows or Linux, PHP or SQL, you can add those particular rules. And then you can enrich that information with the IP reputation list. There's also bot mitigation that is native to AWS WAF, but also you can have rate-based rules that you control, right? So you say, well, a human is not going to try 1,000 times. It has to be a bot, right? And the IP reputation list is telling you that it's probably a bot, and then the proxy is coming from a known proxy. Well, probably it is a bot, right? There's also the WAF security automation with you can deploy with CloudFormation, StackSet, and it allows you to see the logs in real time and react to those logs based on the behavior. You can also buy managed rule from the AWS Marketplace. So if you have a provider in mind that already provides services for you and you trust them, F5, Imperva, Trend Micro, for example, some of that come to mind right now, you can leverage their rules, right? And most of them offer like a OWASP top 10 rule, and then you have API protection or CVE protections and different kind of rules that will adapt to your workload. Firewall Manager can automate the discovery of new applications. So again, you cannot protect what you don't see, right? You saw that in the expo downstairs. There's a big banner that says that, and it's true. So you write the rules for Firewall Manager, and when there's something new, even if when you wrote it that didn't exist, it's gonna get detected, it's gonna get remediated if you want. Okay, and then too long didn't read, layer 7 protection, lives at the edge, we have the bot control. And the last one that I wanna talk before I get Joe here, and Joe, get ready, you're coming, is the DNS firewall. So if you are running in VPC, you have the DNS resolver, the .2 that we call it, right? Because the IP starts with the .2. And you're already getting a lot of information from that resolver. Why not just add a firewall to it? And that's what it does, right? It's highly available. If it fails, you can choose to fail open or close. And if you fail close, you are just giving a lot more of importance to security than high availability, or you do the opposite and you're giving it more to the high availability. So you can filter, you can deny, you can give information when you deny, or you can just give no data to the denied. You can filter on your resolvers or your on-premise resolvers that are connected to the VPC resolvers. You can enforce this from Firewall Manager, and you can choose to do a walled garden, meaning I'm blocking everything and allowing something, only the domains that I need to connect to, or vice versa. I'm just going to allow all and block known command and control botnets. So this is how it looks. You get your instances, you get your resolver, you have a firewall in front of that resolver. If you are using on-prem, from those inbound resolvers, you can also filter. Firewall Manager is what you come to expect. It will enforce that every new VPC has these rules applies to it. Too long didn't read, DNS-based filtering attached to the VPC. It helps to prevent DNS exfiltration of data. It is a regional service, so if you have rules in one region, you need to write them again, and Firewall Manager can help with that. And now, your turn, Joe. Thank you.
Hi, my name is Joe Mathai. I'm a staff security engineer at Airbnb. The topic of my talk, or the goal of the talk, is to help you reduce the impact of a possible security incident that might happen in your organization, specifically by controlling egress access from your environment and giving you a pathway to get started with that. So the idea of controlling your outbound access or your egress access is called egress internet access control. Most people are familiar with inbound access control. If you have an online service on the web, most likely you have either a browser or a mobile app that's connecting via an encrypted connection using HTTPS or QUIC, and it's connecting to your site. And you are protecting your site from bots that are either trying to take your content off your site or trying to take your site down using some kind of DDoS mitigation or rate limiting or some kind of request filtering. Once the actual requests come to your site, you're either authenticating the user based on your business logic. If it's an e-commerce site, you might not authenticate until they need to actually check out. If it's a banking site, you authenticate them right away using passwords or multi-factor authentication, various different kind of authentication models. If you're doing payments, you're doing payment processing, and you want to make sure you're doing some fraud and abuse checks. All of these things are really well understood, and all of these things have evolved over time, mainly because attackers have evolved over time. As attackers have gotten more sophisticated, each one of these layers have gotten better and better. Egress access control is usually not as well appreciated. Egress access control is when your production system is connecting from your production environment somewhere out to the internet. Here, authentication is either done for the server-side authentication. It's usually based on a TLS server certificate where you're checking the thing that you're trying to connect to matches what's in the certificate name. The authentication of your actual instance is usually like an API key that's tied to your environment, to your account, and allows you to do certain things. The things that you connect to are all the things that your business relies on to run its business. So these are vendors, these are third-party partners, these are software repositories, logging services, all of those kind of things. In terms of network and request-based filtering, you might be doing it by domain name or by IP address or by service port. Nowadays, most online businesses use a huge amount of third-party services. And nowadays, most businesses only want their engineering time to be spent on their main product. Users, on the other hand, expect the same level of service on every website that they go to. And what that ends up happening is that you have many connections to many different vendors. Someone who does customer support for you, someone who does payments for you. So you have many different connections coming from your environment to many third parties out there. Some of the assumptions with egress access control is that if I can look at my source code, and if I can look at my configuration, I know what my production environment is connecting out to. If I know what third-party software packages I use in my production environment, I know that if I'm installing this package, this is what the package tells me that it connects out to as part of running that package. If I use a vendor, I know that I'm connecting out to the vendor because I've had some legal or contractual obligation with them. And so these are the assumptions that we often make when we think about egress access control. There's a lot of problems with these assumptions. Oftentimes, all code is usually dependent on other people's code, which is usually dependent on even other people's code. There's a great paper from Ken Thompson many years ago called Reflections on Trusting Trust. On that paper, he talks about how you can even look at someone else's people's source code, and you can't really tell if that source code has been backdoored or not. Nowadays, your software packages, your engineering teams, you're pulling in all kinds of packages from the internet, and some of those packages have security bugs that are just waiting to be discovered. The most recent one being Log4j. But this is a problem across the board. These packages, once they're actually exploited, allows for remote connections out from your environment, allows for reverse shells, allows for remote code execution. This particular example on the slide is showing serialization and deserialization. This is the idea that you take some object in code and you convert it into a byte stream to be able to send it to somewhere else or not. There's often lots of bugs with these kind of deserialization and serialization code. The one that I'm picking on is the Python YAML package. In the Python YAML package, about a year ago, there was a discovery that you load the data and it tries to process the YAML, and it actually does remote code execution while trying to process the YAML. So you go pick up this YAML file from somewhere else on the internet, you load it, and if it's somewhere on the internet that you don't know about and you don't do any validation, you get a reverse shell to or run whatever that person's running. Vendors. Oftentimes, a lot of product managers and engineering organizations at companies are very much focused on time to market. We got to get things out there. Oftentimes, that involves having your product is dependent on some third-party vendor. Now, depending on the size and the maturity of the organization of your company, you may do some vetting of these third-party vendors. But oftentimes, this vetting is very much done at a legal or a contractual level. It's a very high-level check. And so once these vendors actually, you start connecting, and they either have administrative access to your site, or you're sending business-critical data to them, their security is your security at this point. So whatever data you're sending over to them, whatever their environment, you don't really know what they're doing with those things. And that's dangerous. These risks eventually can become legal and business risks for your organization based on how dependent you are on this vendor and what they're doing for you. Oftentimes, egress access control does not prioritize security risk, right? So most times, security teams think about the first parts of an incident or an attack chain. What they're mostly focused on is the things that are the first steps. Usually that's either patching endpoints, making sure people are using MFA, security risk management, pen test, reviewing code, making sure you're doing top 10 best practices in web security. All of these things are important, and all of these things takes immense amount of time. But the assumption should be that an issue will eventually happen, and how do we minimize the impact of an actual exploit? Usually exploits require multiple different exploits to happen to be successful. And so our goal as security engineers is how can we reduce the impact of these incidents from possibly weeks or months to days or hours. And I believe egress internet access control helps us do that. Here are some ways that egress internet access control helps reduce the impact. Usually when a 0-day or a day 1 vulnerability happens, it gets announced in the news, and there are mass scans of the internet IPv4 space. Nowadays, there's tools out there that can span the entire IPv4 space in under 5 minutes. These tools require some sort of callback, some kind of connection back to the server that scanned it to know if you're vulnerable or not. By blocking those callbacks, usually researchers, but even attackers, now move on to the next environment because that callback isn't happening. Web shells are ways that attackers, when they find a web vulnerability, one of the things they try to do is have command of the web server through what's called a web shell. Oftentimes, these web shells are creating connections back to a control server. Stopping that connection stops the web shell. So if that web vulnerability happened, the attacker can't do anything more than just what web gave them. Dependency confusion is a really interesting case. Here, this is when you have private and public code registries, and your build server goes and pulls from the public registry before it gets it from the private registry. What this allows people to do is an attacker can set up a namespace on a public registry, and you go and pull the code down, and you start running the attacker's code as your third-party library. In those things, they can create reverse shells out, connections out, to get back to their systems. DNS, and this is what we're going to talk a little bit further about, is an amazing protocol. It can do almost anything and transport any kind of data, but it's often a protocol used for command and control. DNS lookups are often a way to know if something executed in your environment. Stopping those lookups from happening stops the malware or the attacker from going on to their next step. Large outbound file transfers. Oftentimes people are copying things around, either for good reasons or bad reasons. If someone who's accidentally copies huge amounts of data out of your production environment, egress access control blocks that. Many people think of egress access control as another thing that can fail. It's another complexity in your environment. You're putting something in between your production environment and the internet, and now I have to worry about something else that needs to scale, that needs to be always available. If it goes down, then my production environment can't connect out. In the past, it's usually been solved by proxies or firewalls. Nowadays, with Linux hosts, people run it on host-based networking and run firewalls and proxies on all of those things. Egress internet access control is also an organizational concern. You don't really need it to run the business, right? It's a security control, but you need infrastructure teams to help you manage it and deploy it. Now, even after achieving egress internet access control, you're not done yet. And this is where DNS comes into play. DNS is almost always available. You can have a computer deep in your private network and has no network connectivity to almost anything, but it's still most likely still make DNS lookups to the internet. Almost every system that's online has the ability to make DNS lookups. Public cloud providers like AWS offer DNS resolver. By default, when you pick up an EC2 instance, it becomes the .2 resolver. And this DNS firewall traffic doesn't actually egress your VPC. It goes to the Route 53 resolver, and you don't actually can firewall it or put anything in between it at the network level. This DNS resolver needs to be monitored and secured separately than the connection level. There's certain advantages of monitoring and controlling DNS. Domain names are usually tied to organizations' brands. If Google.com changed its name, it would be we wouldn't be able to find things on the internet anymore, right? It's tied, organizations' brands and the way that we think about them are very much tied to their domain name. What's great about them is that they don't change often. As opposed to IP addresses where an IP address can live on a public cloud somewhere and be tied to a good organization or a good service, and then an hour later can be tied to a malicious entity. And it becomes very difficult to do egress filtering based on IP addresses, but with domain names, we can create a positive model of things that can connect out to. It allows us to create an allow list. TLS server authentication, when you go and make a connection, an encrypted connection to your banking site, in the background, your browser is checking the domain of what you're connecting to the certificate that it receives. It used to be in Chrome, you would get some kind of warning if it didn't match. Nowadays, you can't even connect to these sites anymore. Domain names are very critical in knowing what you're connecting to and allows us to create trust on what the server is. Connecting to an IP address is unusual, and it requires more scrutiny. It doesn't make sense since the certificate is tied to a domain. AWS allows us nowadays to enable DNS query logging. This allows you to see every domain name lookup that's happening in your VPC. It also allows you to enable VPC flow logs. Both of these logs, if you can get anything out of this talk, enable these logs if you don't have them turned on. It's very simple to turn it on. You're not changing anything in your environment. You're just look at the logs and see what you're connecting to. These logs are critical for threat hunting, to know which hosts might be compromised by malware and are connecting out to things that you don't expect. If an application or malware is connecting to something that's not using Route 53, you won't see it in these logs. You'll see the VPC flow log, but you won't see it in the DNS query log. This goes to Route 53 DNS firewall service. Route 53 DNS firewall service, it's a part of Route 53. It's just included as part of it. And as Alvar said, when you launch an EC2 instance, you get a .2 resolver that's auto-configured on your instance. Route 53 firewall is, you can enable Route 53 firewall without changing any configuration on your instances or your applications or making any changes. It's just there as part of Route 53. So when a DNS lookup happens, it goes and it checks that DNS lookup against the policy engine, a bunch of rules that say, is this domain allowed or not? Extremely easy to set up. It supports the creation of rules that allow you to allow and log, or block and log. And the query log can be used to build an allow list. It's attached at the VPC level, meaning that you can, this security control can apply to all of your instances all at once. Our experience at Airbnb with DNS firewall. So at Airbnb, we have many, many different services and servers with various different levels of ownership. We have people who deploy things using Kubernetes, deploying Chef, deploying all the servers that power Airbnb.com, all of our data pipelines, our development, our staging environment, all these different environments, different server roles, and deployment methods. A lot of our infrastructure is very short-lived. We use things like Lambda or ECS, or we have EC2 instances that we launch for about an hour. It's extremely difficult to do a security control that you can easily apply across all of our instances all at once. Our goal in the security team was to improve the security without creating extra operational overhead. At Airbnb, we spend a lot of product engineering time trying to make our product better for a host and guest. A lot of our engineering and our infrastructure teams are very much focused on making the service better. Getting the other engineering teams to deploy something that isn't specifically on that, it becomes extremely difficult. And so our team was looking for a way to improve our egress control without pulling in many other teams and taking away time from other projects. We decided to use Amazon Route 53 Resolver Firewall. What's great about this is you don't have to have expert knowledge about DNS. You don't have to have any experience like managing DNS services in the past. You don't need a 24/7 operations team that manages the DNS cluster. It's managed for you. As I mentioned before, you can create an allow list or a block list at the VPC level, meaning that this security control applies to everything in your VPC, which was very important for us because of all the different systems and types of systems that we had. It's managed in Terraform. It allows any developer to make any change to it. You don't necessarily need to call the security team to make a change. At Airbnb, our production account makes about 5 billion lookups, DNS lookups per day. One of the concerns we had with DNS firewall was, what would the latency be for a DNS lookup if we put something in between it? So we enabled DNS firewall around in December, and we've had it for the last 8 months. And we saw about a 2 millisecond increase in DNS lookup latency. It was okay. Not a big jump. We configured DNS firewall in a fail open mode. And so what this means is DNS firewall completely falls over. DNS lookups happen like they were happening before. Nothing fails, because DNS always has to work. It's been enabled for 8 months in our production environment. We call this Hotel California, based on the Eagles song. You can try to check out at any time, but you can never leave. What I wanted to come across today is a DNS allow list is doable. It's possible nowadays, especially with the AWS DNS firewall. On our side, we run Kubernetes pods on EC2 instances that come up and down very quickly. One of the problems that we found with doing DNS firewall was it was very difficult to tie a pod IP and a DNS lookup to an actual service, because pods lived for very short amounts of time. We created 3 different rule groups. The always allow, this is basically domains like AmazonAWS.com or Braintree.com or PayPal or whatever. These are domains that just, we always has to work. Like, don't ever touch them. Like, the service depends on these domains, don't touch them. And these rule groups actually tie to actually list of domains. Another rule group was called incremental allow. And so incremental allow means basically when new services come up, we add domains into that, so we touch that rule group. And the last rule group was called default allow and log. And so our goal is to get to a DNS allow list, meaning that we want to basically, that default allow and log over time needs to get to 0. And we want to switch it to a block. DNS query logs log the actual rule group that you're matching. So if it's matching that last log line, you can actually look at your logs to see what it's matching. We use Amazon CloudWatch to monitor our rule hits. Some best practices. Switch to a default block for DNS firewall. You should, as I mentioned before, domain names tie to organizations that tie to trust, that tie to your business, right? And so DNS, you can switch to an allow list, and that should be possible. Understand your egress traffic flows. Like I mentioned before, you gotta know what your environment is connecting out to. For us, we're using DNS logs and VPC flow logs to create tighter network-based firewall policy. And then integrate with firewall and threat detection. Long term, what we want to be able to do is if we see something bad in our environment, we want to be able to proactively stop something as it's happening. The takeaways that mainly that I want to get away from this talk is understand your outbound connections, enable DNS query logging, enable VPC flow logging, see what's connecting out from your environment, and domain names tie to actual organizations that tie to actual trust. And you can find a model of what things your company trusts, and you can build that. Thank you.